Okay, so welcome to part 2 for 3.2, solving systems algebraically. So in the first part, we looked at substitution method. So here we are going to look at elimination method. So 3.2, solving systems algebraically. And we are doing part 2 here, elimination method. Okay, so in that last video, the very last example where we had the weird things happening. So that still applies here. So if you end up using elimination method and your variables drop out and you're left with two numbers that are not equal to each other, again, you have no solution. If your variables drop out and you're left with two numbers that are equal to each other, then you have infinitely many solutions. Okay. All right, so for elimination method, we need to cancel. So need to cancel one of the variables by adding the two equations in the system. Okay, and I'll show you what I mean by that. Okay, so for example, suppose that I have this system, 3x plus 5y equals 8. And suppose I have another equation, negative 3x plus y equals 4. Okay, so it says here we need to cancel one of the variables by adding the two equations in the system. Well, if I add these two equations, then here 3 minus 3, that's 0, right? They cancel out. So here the 3x and the negative 3x would cancel out. And then we would end up with 6y equals 12. Okay, and we could easily solve that. All right, so we see here that when we add the equations and we cancel, that the only way they are going to cancel is if they are same number, opposite sign, right? If they are opposites. Okay, so the question is, well, what do we do if we don't have this? We don't have this nice cancellation. We don't have 3 minus 3. What if this were 3 and negative 8, right? So then what do we do in that case? All right, so let's take a look. If coefficients are not opposites, then of course they are not going to cancel. So what we do is we fix it. We fix it by multiplying the equation or both of them. So either one or both. So the equation or the equations by necessary constant. Okay, so let me show you what I mean. Okay, so suppose that I have this system instead where they don't cancel. Suppose I have 3x plus 4y equals 5. And suppose that I have 5x plus 6y equals 1. Okay, so we don't have this nice opposite coefficients so they cancel situation, right? If I add the two equations, I get 8x and plus 10y. Neither one of them cancel. Okay, so what I do is I have to fix this. And first of all, you have to choose, okay, well, what do you want to eliminate? Do you want to eliminate the x's or do you want to eliminate the y's? It doesn't matter which one you choose. Okay, at the very end, everyone will still get the same answer or should get the same answer. Okay, so I'm going to go ahead and choose to eliminate the y's. Again, you could choose x's or y's. If I want to eliminate the y's, then they need to have the same coefficient but opposite signs, right? So what I have to do is figure out, well, what multiple of 4 and 6 can I turn these into? So you have to look for a common multiple. So a number that is divisible by both 4 and 6 is 12 or 24, right? You can use any multiple of 4 that's a multiple of 4 and 6. I'm going to choose 12 because I like to work with smaller numbers. Okay, but if you choose 24, that's fine too. Okay, so what I want to do is turn this one into 12, and I want to turn this one into negative 12. Okay, and I can easily do that because I can turn this into a 12 by multiplying by 3. I can turn this into negative 12 by multiplying by negative 2. So that's what I'll do. Okay, so I'm going to go ahead and copy my system down here. And what I want to do is turn them into 12 and negative 12. So what I'm going to do is I'm going to multiply this entire first equation by 3. And that will turn this into 12. And I will take this entire second equation and I will multiply it by negative 2. And that will turn this into negative 12. So I'll have 12 and negative 12, which will cancel just like this here, 3x minus 3x. Okay, so you have to remember to multiply all the terms. So all 3 of these get multiplied by 3. So I get 9x plus 12y equals 15. And for the second equation, I'm going to get negative 10x minus 12y equals negative 2. And we see here now, and again, don't forget to multiply also that 1 by negative 2. Okay, so we see here that now they have opposite coefficients, and now they would cancel. Okay, so they will eliminate. Okay, and then we end up with negative 1x equals 13, which is easy to solve. Okay, so let's go ahead and take a look at an actual example and solve it completely. All right, so let's go ahead and solve by elimination method. Okay, so suppose I have this system. X plus 2y equals 4. And 2x minus y equals 3. Okay, so you can choose to eliminate the x's or you can choose to eliminate the y's. It doesn't matter. Like I said, everyone will get the same answer at the end. How do you choose? That's really up to you. You know, eliminating one might be slightly easier than the other, depending on the coefficients that you have, but they're both probably not much more difficult if you choose one or the other. Okay, so I'm going to go ahead and choose to eliminate the y's since I already have a positive and a negative. Okay, so if I want to eliminate the y's, then I'm going to try to make these positive 2 and negative 2. Okay, which means that I'm going to need to multiply the second one by 2 in order to get a negative 2 here. Okay, so let's go ahead and do that. Okay, so I am going to multiply this one by 2. Okay, the top one, I don't need to do anything with it. So let's go ahead and bring these over. So the top one remains the same. The bottom one, multiply everything by 2. So I get 4x minus 2y equals 6. Okay, And so now I can go ahead and combine my two equations, and I see here that my y's will eliminate. And I get 5x here, because 1 plus 4 equals, and on this side I get 10. 4 plus 6 is 10. And then solving for x, divide both sides by 5, and I get 2. And again, we are looking for an x and a y coordinate, right? We're trying to find the point of intersection. So we need an x and a y. So far, we only have the x coordinate. So again, once you have one of them, then solve for the other one. So now solve for y. Okay, and so I can go back to any of these equations because the solution should satisfy both of them. Okay, so I will use the top one. So x plus 2y equals 4. I'm going to substitute 2 for x. Subtract 2 on both sides. So 2y equals 2. Divide both sides by 2. So y equals 1. Okay, so we have 2, 1 is our solution. Okay, and you can always go back, plug them in, and check to see if this is correct. Plug in 2. 2 plus 2 times 1 equals 4. True. Check in the second one. 2 times 2 is 4. Minus 1 is 3. True. Okay, so this works. All right, so let's take a look at this one. I want you to go ahead and try it. Okay, and then we'll look at one more example after this. Okay, so go ahead and try this one. Solve by elimination method. And suppose that you have this system here, 2x plus 5y equals negative 1. X minus y equals negative 4. Okay, so go ahead and hit the pause button and then come right back. And regardless of what you choose to eliminate and what I choose at the very end, we should both come up with the same answer. Okay, so you go ahead and choose which of the variables you want to eliminate. All right, hit the pause button and I'll see you in a few minutes. Okay, so here in this case, I am, again, since I have a plus and a minus right here, I'm going to go ahead. Actually, let me do this one. I'm going to do this one to show you what happens when you don't have a positive and a negative. So here I need positive 2 and negative 2. So here I need to multiply this equation by negative 1 in order for that to happen. I mean, not negative 1, negative 2. Okay. So when I do that, my top equation will remain the same, 2x plus 5y equals negative 1. And my bottom equation becomes negative 2x plus 2y equals positive 8. Okay, and so here I see now that my x's will get eliminated, and I get 7y equals 7. So y equals 1. That is only half of my answer, because again, we need an x and a y coordinate. So now I need to solve for x. I will use the bottom equation. So I will use this one here to solve for x. So y is 1. So minus 1 equals negative 4. Add 1 to both sides, and x equals negative 3. All right, so my answer here should be negative 3, 1. Okay, so maybe you chose to eliminate y values. That's fine. You still should have gotten negative 3 for x. Okay. All right, let's take a look at this last example here where we have some fractions, because you will see some systems of equations where your coefficients are fractions. So let's take a look here. Solve by elimination method. So what we're going to be doing here is clearing our fractions. So if you remember that from chapter 1, suppose that we have this 3/4 x plus 2/3 y equals 7, and 3/5 x minus 1/2 y equals 18. Okay, so what you can do here before you start doing your elimination method is clear your fractions. Okay, so if you remember how to do this, if I want to get rid of these fractions here, then find the common denominator and multiply everything, including the 7 here, which is not a fraction, multiply everything by that common denominator. So here, that would be 12. So if I multiply everything by 12, okay, this is just to get rid of my fractions, okay? We're not doing elimination just yet. Okay, so we're just kind of cleaning this up. And over here, my LCD would be 10. So I would multiply this one by 10 just to clear our fractions. We're not doing elimination method just yet. Okay. All right. So if I do that, let's see what we get. Okay. So here, the 4 and the 12 will cancel, and I'll be left with 3. 3 times 3 is 9. Okay. Over here, if I multiply by 12, 3 and 12 will cancel, leaving me with 4. 4 times 2 is 8. And then over here, 7 times 12 is 84. Okay? Now let's clear our fractions. Now we don't have any more fractions in that first equation. Okay, so that's all we're doing for this first step, clearing our fractions. Okay, so over here, I'm going to go ahead and multiply by 10. 5 and 10 will cancel, leaving me with 2. So 2 times 3 is 6. Going over here, 2 will cancel with 10, leaving me with 5. 5 times -1 is -5y. And then over here, 18 times 10 is 180. Okay, and then now you can go ahead and start your elimination method. Decide what you're going to eliminate, x's or y's. Okay, and then solve. Okay, but that's how you do these types of problems. And then after this, I would choose to eliminate x's just because I can turn them into 18 and -18. Okay. All right. So I just wanted to show you how to deal with the systems that have the fractions. So start by clearing your fractions, and then you can use your elimination method. Okay. If you have any questions, make sure you message me. You could, if you decide to finish this one off, I'll write down the answer right now. You can hit the pause button. I'm not going to work this one out, but the answer here will be 20 -12 if you work this out. You'll probably need a calculator. Okay, with these big numbers here. Okay. Again, if you have any questions, message me, email me, let me know what you need. All right, I'll see you next time.